Hey everyone, welcome to my session. My name is Dishan Banga. I'm currently working as senior data analyst with Bridgetree, and today I'm going to present one of my published work called Emotion Detection in Speech. So as the title says, that we are trying to detect an emotion of speech of an individual. So for this research work, we use a data set which will be going through with the methodology, what kind of data sets we use. The main goal was to identify what kind of emotion is present in the person's speech when they are talking to somebody, or when they are doing their daily work, or what kind of speech it is. So going ahead, this should be our agenda for the day. To start with introduction, then we'll come up with our proposed methodology, which was used in building this model for this research work, and then we'll go with different parts of the methodology like data extraction, preparation, our modeling research, and finally the conclusion. So moving ahead, we'll start with the introduction. So as I mentioned, as a topic space, it's the ability of the humans, how they are verbally communicating with each other. What are their emotions when they are communicating? They are angry, they can be sad, they can be surprised, they can be any other emotion. So NLP, natural language processing, is an ability of machine to understand and interpret human language in written or spoken. So for our this research work, we'll be using human audio data and identifying their emotion in their audio, in their speech, using natural language processing. So there are certain factors which helps us in identifying, especially when it comes to the speech, how person is talking. That can be the intensity, how loud or how pressure level when they are talking. That can be their pitch, their variation of frequency. That can be if they are stammering or not. That can be their glottal pulse. It can be their speaking rate, how fast somebody is talking or how nervous they are, like the way I am right now. So how fast they are talking, how what kind of action they are using, what kind of vowels they are using. But for this research, we have maintain our focus to a particular speech, which will be coming across in the next slide. So what that data looks like, and identifying which emotion is present in this speech. So for this research purposes, we have to narrow it down to certain emotions. So there are already some systems exist which identify the speech and other capabilities. So what we are trying to do here is to contribute to system speech and sentiment analysis for the AI. We are implementing predictor models to classify the emotion action of the speech. We would be determining the accuracies and of the different models and identify which one is good, because it varies from person to person or from gender to gender. The way a male person talks is different from a female person. So our proposed methodology, or the pathway to this model is, of course, the audio extraction or the feature extraction from the audio data set, and building a model, training our data set, and then testing our data set, and then calculating at the end accuracy which model works best for which data set. We'll see that in the results section. So now, so for this exercise, we have used the Ravness data set, which is called Radisson Audio Visual Data of Emotion Speech, and we have also used Survey Audio Visual Experimental Emotion data sets, which is again a British English data set. So the characteristics of that data set, it consists of 12 males and 12 female actors, both in audio and the video. So they have different emotions throughout their speech. We have categorized some like neutral, calm, happy, sad, anger, surprise. We have extracted their data files, audio files, in the .bav format. So when we go for our data preparation, we have used those audio files, and then we use Python language, or especially the Python library PyAudio analysis, to extract the different features, to extract the different emotions which are present, or to extract the different characteristics of the speech. And those characteristics, those features can be ZR, ZCR, energy, entropy of energy, spectral score, spectral energy, and other parameters, which will help us in building the model, which will be kind of input features in our model. So for different data sets, we have tried different models. So for the ravenous data set, we have all the emotions included, which we saw in previous slides. These ones, all of the neutral, calm, and all the seven emotions. And then we have used different models like support vector, KNN, random forest, RNN. And then again, we have taken a subset of that Davidness model, which only specified to few emotions, angry, happy, neutral, and sad, and using the same kind of machine learning algorithms to build them. So this slides represents how the different categories of data sets perform across different models. So we can clearly see for the whole data set, random forest is the best model if we focus only the full data set. But when we come down to the subsets, we see for the male and female, KNN perform the best, and for the male subset, random forest perform the best, and again for the female, KNN perform the best. So this shows that these speech detection, speech emotion varies from different on based on various characteristics, and gender is one of them. And then when we combine this data set with different data sets, Berlin and Savvy, which is again in a German language and a British language data set, we use the same machine learning algorithms, and results are as follows. For the male and female data set, for the whole data set, where we used all the emotions, all the seven emotions, KNN performed the best. But when we subset it to particular top four emotions, we see that the RNN model performs the best. So we can clearly see that our model is performing good they have different results based on different algorithms and kind of different data sets being used. These data sets are easily available on our GitHub repository. So our conclusion comes that the accuracy obtained from the data female speaker is more than the male speakers. RN performed the best when we use consolidated data sets considering fewer emotions. We noted that taking bigger data sets improved our result, but not significantly. And then these kind of research, these kind of modeling can have a various potential applications like playing music, changing room lights. We came across some of the few, but yeah, there can be multi wide range of potential future applications for such kind of experiments. And for your reference, this is the published paper on this research. You can read it out online on the given link. And other team member and my partner in crime, Prerna Singh, is also a part of this project. We both published this paper early this year, summer of this year, in IEEE conference. And if you have any questions, please feel free to reach out to me over my email at dishan.banga. I'm happy to answer any questions or look for any kind of recommendations you need. Thank you so much.